Yes, ma'am.
But do they have the same part of speech for every word,
No,
corresponding
no.
words? No. So this should not get that true output, right? That means these
Yes.
two are not similar sentences. So let's check with first option. So for each X in A list, what is the first X in A list? Noun. Now B list has been assigned to C list. So C list and B list are basically same thing. So what is first of C list? Again, noun. Now
No.
these two will match, right? The first if statement will give true and it will directly return true. After this line 5 will it execute? If I return true here, will line 5 execute?
No, no, no.
No. That means this is returning true and saying that A list and B list are similar sentences, right? A and B are similar. So this is wrong.
Yes, ma'am.
Okay. This is saying that for each X in A list, if X is not equal to first of C list. So here
No,
first is, this is noun, this is noun. So will this if statement satisfy?
no.
So will I return anything? No. I'll come to line 5. So in line 5 now, C list is going to be assigned init of C list. So init means which element will be removed? First or last?
Last last one.
Verb is removed, right? If verb is removed, now your C list contains noun and adjective. Okay. Now for the next iteration, you pick the second element in A list, which is verb. Now is X not equal to first of C list? So verb is not equal to noun, right? So it will
Yes.
return false. But again, is this correct way of checking?
No, ma'am.
So what do you think? This option is correct. Let's say if I take two actually similar sentences, let's say noun, verb, and adjective is also there for this B list, right? Then after the first iteration, this adjective is gone. Second time, comparing this verb with this noun again. So this is not correct comparison, right? Because here also it will say that first of C list is not equal to X and it will return false even though these two are similar sentences. So again, this cannot be correct. Now here, okay, let me write it here. This is A list, noun, verb, adjective. This is B list, noun, adjective, verb. Now what is the first in A list? Noun. What is the first of C list or B list, whatever you call it? It is also noun. So again, are these two equal? Yes. So the first if statement goes wrong. Now
Yes, ma'am.
C list is containing rest of C list. What is rest of C list? First one.
Expect the first word.
Everything except the first.
So it will have adjective and verb, right? Now go for the next iteration. What is the next X? Verb, right? Now you check, is X not equal to first of C list? First of C list is what? Adjective. This is correct. They are not equal. So I will return false. That means these two are not similar sentences. But similarly, if I had two similar sentences, if I had this same thing, noun, verb, adjective, then what would happen? Will it give true or false?
True.
So this will work, right? Because first I'll compare the noun with the noun. Okay. And this will give, the if statement will not execute because the condition is wrong. Noun and noun are equal. So again,
Yes.
rest of C list, now you're left with verb and adjective. Now next X is verb. Again, verb and verb if I compare this and this. Again, the first if statement will not return anything. Again, you do rest of C list. Now you're left with adjective. This one is also adjective. So again,
Yes.
the if statement will not work. So now when you do rest of C list, now nothing is left, right? And here also you have gone through all the elements, so the for each block will stop. You have not returned false. So is this correct?
I think it is correct.
The logic is correct till now. Okay, I'll keep this under consideration. Let's see the other options might be correct. We have 5 options. So again, One thing is missing in this option C. What is that? You did not return false because these two are similar sentences, but you did not return true either,
Yes, ma'am. At last we should return true.
right? So if I get to come out of this for loop without returning false, that means after this I should return true, right? This is what is missing from option C. So this will also not work. Option D, what is wrong here?
In line 3, it is returning false, and thereafter at
Here
line
also it is
7
returning.
also it is returning false.
This should be true, right?
This last should be true.
Otherwise, the logic is fine. This line was missing in previous statement, and this statement, the line is there, the return statement, but it is returning the wrong value. So now E option is left. This is correct. Everything is
Yes,
there.
yes, ma'am.
Yes, ma'am. The correct option is clear.
Yes, ma'am. Understood. Yes, ma'am.
Okay. Any other doubt
Um,
from this one?
m- Ma'am, 5 point, sorry, 6.2 activity question. Question number 2, I have the question.
Okay, let me share the portal.
Actually, I'm not clear on that, how it was getting that percentage.
Wait, let me see. Yes. Which one did you say? 6 point? 6.12, what did you say?
Sorry, 6.2. Sorry. Question number 2, activity question is 6.5.
6.5. Okay, wait.
Uh,
You can see the screen?
mm, Yeah, 6.5
Let me open.
in
This,
this
right?
second question. Yes, correct. This second question.
This is a very good question. See,
Yeah, I'm not
uh,
getting on this.
I'll just explain this once, then you will be able to do all the sub questions also. So consider the given lists that have been generated from a paragraph. Now VV, VC, these are all lists. Right. So VV is a list that stores the words which start with vowels, followed by words that start with vowel. Right. VC is it stores the words which start with vowel and followed by words that starts with a consonant. CV is just the opposite of that. It stores words that start with consonant but followed by words with vowel. And CC is words that start with consonant and also followed by words that start with consonant. So, should there be anything common in between these lists?
Uh, Common.
Any
Vowels can
common?
Vowel, vowel is common in the all three, first three.
See, VV is storing the words that start with vowel and are also followed by a word that starts with vowel.
Okay.
So, can there be anything in common between VV and VC? Let's say a
the
word
thing that
starts.
they start with the vowel is common.
They start with a vowel is common, but are the elements or the words actually common between these lists? Not possible, right? If
No,
a
no.
word that starts with vowel and is followed by a vowel, then it cannot be followed by a word that starts with consonant as well, right? Only one thing is possible at a time. So there is nothing common in between them. Okay, these are disjoint. So lengths of the lists are given below. Wait, for your understanding, let me just quickly write. Can you see this?
Yeah, just loaded. I'm able
See,
to see.
VV is a list that contains words like this. Okay. Let's say I am. So can I store I
Yeah.
in VV? Right. Then again, go to VC. This might be I was. So are these two I's part of the same sentence? Is this sentence same as this sentence? No.
No.
No, no.
The words may be common. Okay, but they're in different sentences.
Yes,
Or
ma'am.
even if they're in the same sentence, they're not the same word. Because either it is followed by vowel or it is
Ma'am,
followed by consonant.
But am and other consonant word will come, right? For example, name anything
Yeah,
you can.
something else will come. Right.
So
Anything
then,
can come. I don't know what will come after and am.
okay,
So
for
if I
example,
say that,
after
let's say,
am,
yeah,
you will get the
mhm.
consonant name, something name.
Let's say I am going home. Okay, this is my
Okay,
sentence.
okay.
So in that case,
Now,
am should be in VC list,
yeah.
right? But I should be in VV list. So it will
So,
go the same way as this for the consonants as well. Okay, now
okay,
let's
now I
see
got.
the rest of the
Okay,
question.
ma'am, now I got it. But how the percentage is calculating to 75? That is also
Hmm.
I'm confused on this question.
We'll see. See. CV and CC. Okay, these are all clear now. Now lengths of the lists are given below. So the VV length is 5. So 5 words are there. VC is 15, CV is 20, and CC is 60. So what
Yes.
percentage confirm the hypothesis that words that start with consonants are followed by words that start with consonant? So this is a hypothesis that every word that starts with consonant will also be followed by a word that starts with consonant. So which list actually stores such words?
Yes.
CC list stores such words that start with consonant and are also followed by consonant.
Yes, correct. 60.
60 is there. Right.
Mm.
Now, what is the total number of words that actually start with consonant regardless of what they are being followed with, vowel or consonant? What is that total number?
100 here.
60 and 20,
3 and
both.
20.
Right. These are both storing words that start with consonant. Now, regardless, I don't care what they are being followed by, vowel or consonant. That's the total set. Right. From that, I want the hypothesis that how many words are there that are starting with consonant and are also followed by consonant. So that is 60. So it will be 60 by 80. So what is 60 by
Okay.
80? How much percentage is that? 75%. Look, here's the logic. I'll just share the PDF again. See, this is the entire set. Okay, this is the set of words that start with consonant. Okay, so this will contain all the words from list CV plus list CC. This you agree?
Yeah, I agree this.
So this is some 20 and this is 60, right? So the total number of words that start with consonant is 80. Now the hypothesis is that every word that starts with consonant will also be followed by consonant. So how many are such words? 60.
Okay, okay. Got it.
So the percentage will
Okay,
be this.
75. Okay, ma'am, now I got it. I
Okay, you
put
can do the
for
rest.
rest of them. Okay.
Yeah. So just see, take the sets that are similar. Like if I say the same for vowels, so now you will take all the vowel words that start with vowels, and then you take out the set that your hypothesis is asking, like vowels that are followed by consonants or vowels that are followed by vowels.
Okay, ma'am, now I got it. Thank you.
Okay. Yeah. Any other doubt in week 6?
No, ma'am, thank you. From my side, it was clear.
Okay. Anyone else? Then I'll start with week 7. Can you see the slides? Visible?
Yes, ma'am.
Okay. Yes, ma'am. So week 7 is about dictionaries, right? It is also a kind of a collection, such as lists only. But dictionaries have a few more rules than lists. And again, there are some functions that are related just to dictionaries that you can use just on dictionaries, not on lists. Okay, like in list, we had this first of a list, last of a list, innate, rest. Like that, in dictionary also, we have a few functions. Okay, this is another type of data container, basically. So a dictionary looks like this. If I say D is an empty dictionary, so this is the symbol for that, open and closed braces. So list, we use what? Box brackets. In dictionary, you will use braces. Right. Now, in dictionary, every item is of this form. A is to B. This is one item in a dictionary, one element. So this on the left-hand side of the column, this is your key. And this is the corresponding value. Okay. Now, in dictionary, the rule is that all keys must be unique. So I can have another key value pair like this. Okay, A and C are unique. But I cannot have this after that because C and C are not unique. But I can have this. Okay, and this eraser is not. Okay, fine. See, I can have this. I can also have this. So the values can match. Okay. But the keys should all be unique. Values don't have to be unique. So any number of such elements you can have in a dictionary. Now this is a data structure that you will be using in Python as well. So indexed collections. See, a list does what? A list has an index, right? A list keeps a sequence of values. You can access any value through its index, right? So you can iterate through a list, but random access is not possible. So if we want to get a particular value, if I want to go through a list and find a particular value, I'll have to iterate through the list from the first position to the last position. Wherever I find my value, I'll stop. So to find an element in a list, we iterate through it. To get the value at position I, you need to start at the beginning and walk down I minus 1 steps till you reach that index. But a dictionary stores key value pairs, like I did, that A is to B. So A is the key, B is the value. For instance, chemistry marks. So for students, the course data set, if I create a dictionary like this, let's say for an individual student, this is how I'm storing his marks. Physics 80, chemistry 70, maths 90. This is a valid dictionary. Are any of the keys matching? No, right? But if any of the keys are same or duplicate, then it is not a valid dictionary. So this is one example that you can have chemistry marks as the value for each student as key. This also you can do. If I am creating a dictionary that just stores chemistry marks, then you can take the student ID as the key. Because student ID is unique. So student 1 has marks 80, student 2 has marks 70, like this you can do. Then again, source station can be the value for train route, right? All the basically you have to make sure the keys are unique values. So present the key to extract the value. This is how we extract values from dictionary. We don't have to go index wise. There is no index here, right? Here we use the key to get the value. So it takes the same time for all keys. So random access is possible in dictionary, but not possible in lists. So let's say if I create this dictionary chem marks, right? And I'm taking the student name as the key and the chemistry marks as value. So for Rahul, if I have a key value pair like this, Rahul 80, and the dictionary name is chem marks. So I will write chem marks in box bracket. You will mention the key and that will give you the value. So you can store the value in any variable you want, like M here I'm storing. Similarly, for another dictionary like source station, you can take the train number as the key. And let's say against that, the value stored is the source station for that train route. So that will be now stored in S. So this is how you get the value, right? You first name the dictionary name and then in box brackets, you give the key for which you want the value. Now this is the pseudocode. So this is the sequence of key value pairs. Like if you're creating that Chem Marks dictionary, then Rahul 92, Clarence 73, Ritika 89. These are all different entries. Empty dictionary is just empty braces. You can access the value by providing the key within square brackets. Now see here I am using strings, right? It doesn't have to be a string. The key can be anything. So if you are using a string, then you give these inverted commas to enclose the string. Okay. What else? So a dictionary must exist to create a new entry. So whenever you want to create an entry, first have to obviously initialize the dictionary. So first create an empty dictionary, then you can insert the values or whatever you want. Okay. Now let's take an example. So collect chemistry marks in a dictionary. So this is that chem marks dictionary. So first, before we insert any value, we have to initialize the dictionary. So chem marks is initially an empty dictionary, right? Now, while table 1 has more rows, so we'll go through the entire scores data set, and for every card that we read, for every row X, name is the variable where you store X dot name, right? That is the name of that particular student whose card you have picked. And marks is the variable where you store their chemistry marks, so X dot chem marks. Now, how will you insert this value in your dictionary? So this is how you create a key value pair. Chem marks for the current name should be assigned the value marks. Right. So for every iteration, this will do the same, that for every student name, it will assign the marks. So this will create a new entry at each iteration. But you have to make sure that no two students have the same name, because then the dictionary becomes invalid. See, since this is how you access the values, right? If two people have the same name, then you cannot access their marks, right? Because you don't know whose marks you are getting access to. So this is how you can create a dictionary and insert values in it. Now, how do we iterate through a dictionary also? Obviously, you can iterate through it. You can go through each element one by one, but not how we did in case of lists, right? In lists, you can directly access the elements one by one, right? But here, to access an element, you need the key, right? So what we will do if we want to iterate through a dictionary is first we will run this function. So this is a dictionary specific function called keys function. So what does keys do? It gives you a list of keys of dictionary D. So if I write keys of D, where D is a dictionary, then this will return what? Just running this function will return you a list of all the keys, K1, K2, whatever is there. Not the values, just the keys. Now you can iterate through the dictionary by using the keys. You have the keys in your list. So now just go through the list one by one like you usually do using a for each block. So for each K in keys of D, so first K is K1. So do something that is whatever you want to do with that value, D of K. That is D of K1, D of K2, like this one by one, you'll be able to access the values. Up to now, is it clear for everyone?
Yes, ma'am.
See, so I want to compute the average marks in chemistry. So I already have my chem marks dictionary where against each student name, his chemistry marks is stored, where I am considering that all students have distinct names. So they're eligible to be keys. Now I want to calculate the average marks in chemistry in the entire data set. So for average, again, we need a sum variable. We need to keep the count and then do sum by count, right? So this sum variable I'm initializing as total equals 0. Count is also initially 0. Now for each K in keys of chem marks, this will give you what? List of student names, right? Student 1, student 2, all these names you'll get in a list. These are the keys of chem marks dictionary. Now for each key, you need to add their chemistry marks to the total. So total equals to total plus chemistry marks of K. That is that particular key in that iteration. So after that, you also have to increment the count. So this you can just directly increment. That is each iteration is for each particular student. Now after the for loop is over, total will contain what? Once the for loop is over, what will total contain?
Total chemistry mark.
Sum of chemistry marks of all students, total chemistry mark. And count is what? Count is number of students.
Number of students.
So after that, you come out of the for loop and you calculate the chem average, which is total by count. That's the average, right? So you can iterate through dictionaries, but for that you need the list of keys, and then you can normally use the for each block. Now, how can you check whether a key exists in a dictionary, right? So the use of a dictionary is to accumulate values. Basically, we are interested in the values, but to access the values, we need the keys. So let's say I have this runs dictionary where I have stored that which cricketer has scored what runs. So if I ask that, okay, what run has Kohli scored? So runs of Kohli This will return you the runs scored by Kohli, right? So process a data set with runs from different matches. This can also happen, right? That you have each cricketer has played multiple matches. So I want to process all the data from every match. So each time I see an entry for Kohli, I have to update his score. Right. So I have a data set where there are multiple entries for the same player. Just a data set. Okay, this is not a dictionary. You have a data set where it contains that what runs each player has scored in different matches. So of course for Kohli there will be more than one entry if he has played in more than one matches. So wherever you see an entry for Kohli, you need to update his score in the runs dictionary. So runs of Kohli will be updated like this. Every time you see his name, you will add the score to runs of Kohli, this entry. So let's take a proper example of this. Mhm. Don't think the pseudocode is given here. Okay. So they're saying, what about the first score for Kohli, right? So if I want to know what is the first score that I see in the dictionary, in the data set, right? In in that case, when I encountered the first entry in the data set, do I already have a key called Kohli in my dictionary? This is my data set. Let's say row one has Rohit Sharma's score, then row two has Kohli's score, right? And then some other. Then here again, I find another entry for Kohli from a different match. So first time that I initialize my runs dictionary, it will be an empty dictionary, right? Now I go to the first row. I want to process the score. Let's say Rohit Sharma has scored 8 in that match. So how will I create that? Do I already have an entry for Rohit Sharma in my dictionary? Do I have an entry or do I need to create one?
Create
I need to
one.
So you will write like this, insert the entry in the dictionary. So runs of Rohit, let's say, is 80. So now your dictionary looks like this. That for Rohit 80, this is one entry. Now next time you see Kohli's entry. For that, do I have an entry in my dictionary? No. So again,
No.
create it. So every time you see a new key, for that you have to create an entry. So for Kohli, now I will store, let's say he has scored 100. So I will store 100. Now my dictionary has two entries. Kohli has also scored 100. Now I will process the other rows until I reach this row. So now when I see this, let's say Kohli has scored 95 in this match. So now, do I have an entry for Kohli already?
Yes.
Okay. Should I create another entry or should I update this entry?
Update.
Update them.
Update. So now what I'll do, I'll just call the value and update it, right? So I need to update what value? Wherever Kohli's runs are stored. So runs for Kohli, that will give me the current value stored against Kohli as a key. So runs of Kohli is equal to runs of Kohli by plus the current score, that is 95. So plus 95. So I will obviously store this in some variable, let's say score. So I will add that current score here. So the entry is now updated. So now in my dictionary, instead of 100, it will show 195. Is it clear?
Yes.
So how do we know whether to create a fresh key or update an existing key? Right, this is the question. Here I showed you that, okay, I didn't have a key, so I'm creating. But when you are just processing a data set, how do you know that whether this entry is already there or not? Right. So for that, we have another function called isKey. So this checks the membership of a key, right? So isKey function will take two parameters. One is the dictionary name D and another is the key that you are searching for. So after I create that first key value pair for Kohli, next time when I encounter a row that again has Kohli's runs, so then I can pass it through this isKey function. So I will write isKey. Here I will pass the runs dictionary and I'll pass the key Kohli, right? What will this do? This will give me true if Kohli exists as a key in runs dictionary. And it will give me false if it doesn't exist as a key. So if it already exists and it returns true, then I will just update the value. And if it returns false, that means there is no such entry. So I'll create a new entry. Okay, that is your isKey function. So this keys, is key, or are all are dictionary functions. So typical usage is like this. The thing that I wrote, that if is key returns true, if is key. That means whatever this returns, if it is true. So if true, then you update the score, else you create a new entry. Okay, is key is a very important function. Now, checking for a key again, see this one. Implementing is keys, D, comma key. So this is actually showing you how this is key function internally works, right? So it basically just iterates through the keys of D, searching for your given key. So keys of D is returning what? What does keys of any dictionary return?
List of keys.
List of keys for that dictionary. So what isKey procedure actually does is, first it sets a flag variable called found and it sets it to false. Okay, initially it is false, that is I have not found the key yet because I haven't searched yet. Now for each key in keys of D, so now you have all the keys in this dictionary. Now you go through the keys one by one and check if any of them match the key that you are looking for. So if for some key it is equal to K, that means this key already exists in the dictionary and found is set to true. You can directly exit the loop. And if you go through the entire list of keys and you don't find this K value, then this exit loop statement will never execute and found will never be set to true. Found remains false. So it'll come out of the for each block and return that false value of found. That's the internal working of this isKey function. Is this clear for everyone?
Yes, ma'am.
This is okay. So this isKey will take how much time? That is whatever is the size of your dictionary. If your dictionary has 10 entries, it will take small amount of time. If it has 1 million entries, it will take a large amount of time because it is just doing a linear search, right? One by one, it is searching through the keys. So of course, for worst case, it will take order of n time. So this is something again I won't discuss further because time complexity is not part of CT. Later on, you will study time complexity when you go for data structures course, right? So checking for a key, this is done. Random access is there, right, in dictionary. So what is the summary of what we learned is dictionary stores again a collection of key value pairs. It is a collection. Both lists and dictionary are collections. List stores just elements, individual elements. It doesn't have any pairing. Dictionary has key value pairs. Random access is not there in list, but it is there in dictionary. You can directly access any element using its key. But for list, you have to iterate through the list. Dictionary is again, it maintains a sequence like this: key 1, value 1, key 2, value 2, like this. However you create the dictionary, it will come in that sequence. Usually you create an empty dictionary first and then you add the key value pairs. First your dictionary needs to exist, then you can insert the values, key values. How to iterate through a dictionary? You have to first use the keys of D function. This will give you a list of all keys of dictionary D. Then using that list of keys, you can iterate through the dictionary. And isKey does what? It checks membership, whether a key K is a member of dictionary D. Right? If it is a member, then it returns true. If it is not, then it gives false. Any doubt till now?
Ma'am, member in list and is key in dictionary are equivalent, na?
Yeah, it is equivalent. Okay. Yes. Any other doubt in these slides, whatever we did till now? So I'll just go through the rest of week 7 content, then we'll just start with the activity questions. When is the graded assignment deadline for week 6?
On 25th.
So we're pretty ahead of schedule. So week 7 was supposed to start around Saturday, I think. Okay. So now these are just examples, right? Week 7 has nothing else, just dictionaries. That's it. So we'll do some of the examples, then let's start with your activity questions. So customers buying food items. What data set is this? Shopping bills, right? So we
Yes,
have to
ma'am.
find the customer who is buying the highest amount of food items. What is the condition? Has to buy the highest amount of what type of items? Food items, right? So we want to find that customer. Now we will execute this using dictionary. So first, how to go about this? We create a dictionary to store food purchases. Right. Who are the keys? Customer names. Because customer names are in our data set, customer names are what? Unique. So I can use customer name as keys. Right. Now one customer might have purchased multiple items. So whenever we find a duplicate entry for the same customer, we will create an entry or will we update the entry. If I find duplicate entries for the same customer, do I need to create new key value pair or do I need to update?
Update the key value pair.
Update existing key, right? So first we will create this dictionary where we store customer names as keys and number of food items purchased as the values. Right. So every time I see that a particular person has purchased one more food item, I'll just increment the value against that person's name. So food D is that dictionary. Initially it is empty. Now I'll go through the shopping bills data set one by one and I'll read the first row. Okay, so you read the rows one by one. If I pick row X, then customer is a variable in which I'll store the name. So X dot customer name is stored in variable customer. Items is a variable where I store X dot items. What is this actually? X dot items? This is the item list, right?
Yes, ma'am.
List of items that person has purchased. Now I need to find a specific category of items that is food. That means now I need to go through this list items. One by one, I have to check that each item, what is the category. If it is food, then I will consider it. Otherwise, reject. So for each row in items, that is for a particular customer, this item list I have now stored in items. Now I'll go through the items one by one. For each row in items, if row category is food, the item belongs from food category, then you enter the nested if. And now you check the membership that does this particular item. Does this particular customer already exist in food D dictionary, right? So is key food D customer. So for this particular customer, if he already exists, then I'll just add one to the value. That is, he has purchased one more item in food category. But if it is a brand new customer for whom there is no entry, then you just create the entry. So currently I've found a new customer and I'm assigning it 1 because he has purchased at least one item from food category. This is the first row I found for this customer. In future, I might find more duplicate rows for this customer where he has purchased more food items. So then I will just update the entry. So this pseudocode will work. Is there any error? Anyone didn't understand this?
Ma'am, this customer should highest amount has to be captured, right? Here, number of item you are capturing it.
Yeah, it is. See, the question is that who is buying the highest amount of food items? That is highest number of food items, not the price. Okay, so every time I find an entry for a food item, I'm updating that by +1. So at the end of this while loop, what should food D contain as a dictionary? Food D, let's say for this customer X, if they have got 7 food items, then it is X:7. Again, for another customer like this, it will continue. So this values are calculated how? That every time I'm encountering a card for this particular person. Okay, I'm sorry, not card. For a particular person, I have a card, right? And it has the elements in it, that is items, what all items it has, this particular person has purchased. So that list is here in items list. Now I am going through the list one by one. As many food category items I find, I will update the value by +1. So at the end of the entire while loop, the food dictionary should have what? Customer names, distinct customer names as keys and corresponding values and number of food items purchased by each customer. Is this clear?
Yes, ma'am.
Any doubt, anyone? Then the birthday paradox problem is also there, right? So we have to find a birthday that is shared by more than one student. Okay. So again, how can you do that? So you can just create a dictionary with dates of births as keys, right? If I take DOB as the key, each date is unique always, right? There are no two exactly same dates. So if I take date of birth as my key in this birthdays dictionary, then for each date of birth, what can I calculate? That how many people were born on this DOB.
Same.
right? So if I see that uh, for any DOB, the corresponding value is more than one, that means I know more than one student was born on this date of birth, right? But see, what they are doing here is create a dictionary with dates of birth as keys. This is fine. Then record duplicates in a separate dictionary. So see, first I have birthdays dictionary, then I have duplicates dictionary. Okay. Now, while table 1 has more rows, read the first row in table 1. DOB is a variable where I'm storing the dates of births. So x.dob is stored in DOB. Now I'm first checking that does this DOB already exist as a key. So I'm checking if is key birthdays DOB for this particular date of birth. Okay. If it is true, that means if this is true, that means what? This DOB is already a part of birthdays dictionary. That means at least one student already has this date of birth. Right. So if this is true, then duplicates dictionary, you will create another entry for this same DOB where you assign it the value true. That means there are duplicates for this particular date of birth. That is more than one student has this date of
One
birth.
has same.
Yes. So first you created the key, right? Now let's say I have a brand new date of birth for which I have not seen any student before who has this date as their birthday. Right. For that, is key will give true or false here. For a new date of birth, which I haven't encountered before.
False.
It will give false. So you'll come to the else part and create the entry in birthdays. So in birthdays table, basically we are just having all the entries of the distinct date of births. Now, while we go through the list, let's say for 5th Feb, I have first encountered a card. Okay. So in birthdays dictionary, I have assigned this as true. Fine. Now let's say another card I have encountered who also has this same 5th Feb date of birth. Then for that, in duplicates dictionary, I will create an entry. Duplicate DOB. So this will be 5th Feb. And I'll set the value as true. So these two are separate dictionaries. Duplicates dictionary stores which date of births?
Which have already in. Which are
For
not unique.
okay, tell me the difference between birthdays dictionary and duplicates dictionary. Will they have all the same key value pairs?
If there is one, say 5th February occurs one times, it will happen in
Birthdays dictionary.
yes. Again we encounter 5th February, then it will come under duplicates dictionary.
Right. So that means all the date of births that come under duplicate are definitely a part of birthdays. Right, because every new date of birth I'm storing as an entry in birthdays dictionary, but for only those date of births for which I am seeing multiple entries, for them I'm creating an entry in duplicates. That means duplicates dictionary just contains those date of births on which more than one person has been born. Yes or no? Let's find
Yes.
it up to this. See, this will get a bit more complicated now. So now they're saying that, okay, I have birthdays, I have duplicates. If we want to record the names of those people who share a birthday, and store a list of student IDs against each date of birth. That means now I also want the names of the people who are born on the same day. And I want to store a list of student IDs against each date of birth. That let's say for 5th Feb, student ID 1 and 2 are born. So it will look like this. 5th Feb is the key. And list can also be a value. So let's say student ID 1 and 2. So this will be one entry of the dictionary. List can, values can be anything, right? A value can be a list, a value can be a dictionary, a value can be a single number, a string, whatever you want. So this is what they're asking. So now to keep a track of this student ID or the sequence number, that means I now need to take another variable which stores a sequence number for every student, right? So what are the new lines I have to add in my code? That every time I read a row X, previously I was just storing the date of birth in DOB. Now I'm also storing the sequence number in the sequence number variable. Next, it is same. I'm checking that does this date of birth already exist in birthdays dictionary? That is at least one person already has this date of birth that we have encountered. Then duplicate is in duplicates dictionary, we create this entry for this date of birth. But we also want to store a list of student IDs who are born on the same birth date, right? So in birthdays DOB, what is this sign?
Appending list.
Append, right? So that means now in birthdays dictionary, every entry looks like this, right? Every entry has a list stored against it. Look, let's take a quick example. Let's say I first encounter a birth date, 2nd Jan. Okay. I'm saying that my birthdays dictionary at this point is also empty. That is, this is the first entry I'm seeing in the data set. And duplicates is also empty. So now I check the first card. It has birthday as 2nd Jan. Okay. And let's say the sequence number is 1 for this particular student. So DOB stores 2nd Jan, sequence number stores 1. Is this date of birth a key of birthdays dictionary? Right now? If this is the first card I'm seeing, is it a key of birthdays dictionary?
No.
No. So I'll create the key value pair. So is key will give false. So come to the else part. Else part is saying birthdays DOB, that is for this date of birth 2nd Jan, create an entry in the dictionary. But what is the value that I'm storing against this entry? Sequence number inside a list, because I want list of student IDs, right? So now birthdays will look like what? 2nd Jan is a key against which I'm storing sequence number 1. This is fine.
Yes.
Now let's say the second card I pick is also of a student who is also born on 2nd Jan and their student ID is 2. Now for this again, when I check if is key birthdays DOB, this is key will give what? Correct? True or false?
True.
True, because I already have an entry for 2nd Jan. So now in duplicates dictionary, I will store this 2nd Jan as a date of birth that has at least more than one person who was born on this day. So here the entry is true. But I also need to add this sequence number to the list of IDs, right? So this will be appended here. Along with 1, I will also have 2. That's why this append is here. Is this much clear? This append is
Yeah.
happening on this slide. Okay. Now, one more thing they want to do is they're saying that we can also store the students associated with each date of birth as a dictionary.
Ma'am,
Right.
could you please repeat the duplicates?
Which one? This.
Duplicates, deal.
See, duplicates dictionary only stores those date of births on which more than one people have born. Right. If it is the brand new date of birth, then you create an entry in birthdays dictionary. But if you again encounter that same date of birth for another student, then you create an entry in duplicates dictionary. So this will only happen when you encounter a date of birth that already exists in birthdays. That means more than one people are born on this day. But every time you encounter a duplicate, you also need to make sure that for that duplicate student, their ID is also added to the list of sequence numbers in birthdays DOB for that particular date. Now, one more thing that they're adding to it is, can we also store the students associated with each date of birth as a dictionary? So this is nested dictionary concept. That is dictionary inside dictionary. So this will look like this. Let's say the birthdays dictionary was first. Till now it is looking like this, right? For 2nd Jan, I have 2 students who are born on this. So sequence number 1 and 2. Then again for 5th Feb, I might have only one person born on this date. So it's a sequence number 3 and so on. Right? Now they want that instead of storing it like this, I want to store it like a dictionary. Right? So what is changed here? Birthdays, duplicates, everything is same till this line. So whenever we have nested dictionaries, we need to access both the keys. Look, okay, I'll again start from the empty birthdays dictionary. Okay. So first card I encountered, student is born on 2nd Jan, sequence number is 1. So how is the birthdays dictionary getting updated? DOB is 2nd Jan, sequence number is 1. Is it a key? No. So create a new key. So you'll come to the else part. For this DOB, let's create a new key. So 2nd Jan, I'm creating a key. Against that, see the value is an empty dictionary, right? In this empty dictionary, now you are assigning the sequence number as a key against which the value is stored as true. That means for sequence number 1, the value is true. Now when you encounter the next card, 2nd Jan again for student ID 2, what will happen in birthdays dictionary? In duplicates, I'll create an entry that 2nd Jan true. But in birthdays, what will happen? We have found another person. So I need to add them to the nested dictionary as well. So this line will execute birthdays DOB sequence number true. So now the sequence number is 2. So against 2, there will be another true value stored. This is nested dictionary, right? So if I want to access, let's say this value, that I want to know that against sequence number 2, what value is stored? Is it true or is it false? Right? False is not assigned anywhere. So let's say I want to find out that against this entry, what is stored. So how to access such nested dictionary keys? First you give the outer key, then you give the inner key. So in birthdays dictionary, if I want to access this sequence number, okay, what is the value stored against this? How will I write it? Birthdays, first key is what? Outer dictionary key is what?
Date of birth.
2nd Jan. Now for 2nd Jan, I have a whole nested dictionary as the value. Now for which student ID am I checking? Let's say student ID 2. That is the nested key. So first 2nd Jan, then 2. Against this, now if I run this, what value will I get? True. Because true value is stored against student ID 2 for 2nd Jan. So this is how you access nested dictionary entries. Any doubt here? Anyone?
The dictionary should have only one parameter, value, always. Why we need to create the duplicate dictionary here?
See, in this particular, duplicates dictionary is created to keep a track of what are the date of births on which multiple people are born, right? Not unique date of births. For that, the duplicates dictionary is created. The birthdays dictionary will have all given date of births. Whether one person is born on it or whether multiple people are born on it, all date of births will be stored in birthdays dictionary. But we are also creating a nested dictionary inside birthdays. That is for every key in birthdays dictionary, which is a distinct date of birth. The value is what? Another dictionary, in which the keys are what? Student IDs, right? And against every student ID, I'm creating a value that is a true value. Just assigning the true value. This is not very, I would say, it's very helpful. It's not in this case, but it is helpful in other cases to create nested dictionaries. We'll see the actual applications. This is just to make you understand the syntax. So nested dictionary, how to create is that syntax clear?
Yeah, that's syntax clear.
So this application we'll see in the problems when we solve, okay, where to use nested dictionaries. This is not a very good example of why to use nested dictionary because you are only storing true values. Okay. But yeah, for nested dictionary, you have to first give the outer dictionary key, then the inner dictionary key.
Okay.
So for resolving pronoun, now this is a problem that we have that in that paragraph words data set, let's say. So a pronoun is what? A pronoun is referring to a noun, right? So I can say that Rahul is studying in college. he is a good student. So this he is a pronoun which is referring to Rahul. Right. So how do I know that which pronoun is referring to which noun? That's the pronoun problem, resolving pronouns. So I have to resolve each pronoun to the matching noun. So what is that matching noun? The nearest noun which comes before the pronoun, that is usually the noun, right, that it is referring to. So if this is the sentence, this he is the pronoun, right? What is the nearest noun that is preceding it?
Rahul.
Yeah, what is the nearest noun which is preceding it? Is it Rahul? It is actually college. College is also a noun, right? But is this he referring to college?
No.
It is referring to Rahul. So that's where the problem comes, that you are not sure that what is the noun that this pronoun is referring to. So you cannot just say that it is the preceding noun. It might not be, right? So what to do about that? We actually cannot resolve this problem 100% here. You can do it in theory, you can do it, but here we are just keeping in mind that the nearest preceding noun, we are considering it as the noun that the pronoun is referring to. Even though that might not be the case always. Here, maybe 80% cases will pass, but some 20% cases will not pass, like the example I gave you. But we are just trying to do our best and just do it for that 80% cases. So how to resolve that using dictionaries? So you have to create a dictionary with part of speech as keys, stored in, uh, which stores what? Sorted list of card numbers as its values. So part of speech is an empty dictionary initially. Now in part of speech, I have a noun key and a pronoun key. Okay. So against noun key, what is stored? This is, let's say, part of speech dictionary. Noun is a key. Against that, what is stored initially?
Empty list.
Empty list.
Empty.
Then pronoun is a key. Against that also empty list is stored. Now while table 1 has more rows, read the first row x in table 1. So if x dot part of speech is equal to noun, right? Okay, let me take an example. So Rahul is working. He is busy. This is the pronoun, this is the noun. Okay. So read the first row. What is the first row, Rahul? Right? Is the part of speech noun? Is Rahul a noun?
Yes, ma'am.
Yes.
So if so, then in part of speech dictionary against this noun key, what am I appending in the list? The serial number of this card. So let's give them some serial numbers.
Serial
1,
number.
2, 3, 4, 5, 6. So for Rahul, the serial number is 1. So now the dictionary is updated. So noun, for that I have serial number 1 stored. Right. Next, you will come out of this if and come here. Okay. Wait, I think this is the while loop, right? This brace is coming from where? Wait, let me first take care of the braces. I think they're missing this. This should be a brace, right? After if, you need to give a brace, not third bracket. So that's a typo. This is actually the ending of this if statement. Okay, and this is also the ending of this if statement. The actual while loop ends here. So after the first if statement is over, now come to the next one. If part of speech is pronoun. So is Rahul a pronoun? No. So we won't do anything. Now go for the next word. What is? Is. Is a noun?
No.
Is also not a pronoun. So nothing will happen. Working. This is a verb. Again, nothing will happen. Next card is he. He is a noun.
Pronoun.
It is a pronoun.
Pronoun.
Now, your pronoun list will be updated with sequence number 4. I'm not checking for the rest, but yeah, it will update like this. Okay, so now I have created this part of speech dictionary where, like this, let's say the next noun comes at some sequence number 7, then the next pronoun comes at, let's say, sequence number 10. Like this, it will be stored in sorted order because we are going through the cards one by one, right? In sorted order. So the stored list of card numbers are also in sorted order. So how will you resolve it now? Iterate through the dictionary to match the pronouns. So see, match D. Okay. Make sure that you understand this part, that part of speech noun and part of speech pronoun. Whatever list of card numbers they are storing or sequence numbers they are storing, they are always in ascending order because we are sorting the entire data set in ascending order. So we will go one by one only in increasing order of sequence number. So now I'm creating a third dictionary which is match D. So here I'm going to match every pronoun to its corresponding noun. So for each P in part of speech pronoun. So what is the first P in part of speech pronoun? What is the first sequence number?
4.
Part of speech pronoun will give me this list, right? 4 and 10. What is the
Yes.
first item here? 4.
First is first.
So for each P in part of speech pronoun, first P is 4. Matched is a variable where I'm storing -1. We'll see why. Now for each N in part of speech noun. So part of speech noun will give me this list, 1 and 7. So what is the first N? 1. Is 1 less than 4?
Yes.
Yes. So I'm saying matched. And matched will store what? N. That is the corresponding noun sequence number. That is 1. Else exit loop. That means if the first pronoun is at a lower sequence number than the first noun, that means the pronoun is not preceded by a particular noun. So then I will just exit the loop. I'll not do anything. I'll exit the loop and then I'll come to this statement. No, not even this statement. This is also part of the loop. I'll just exit the loop. Exit out of it. Outside the loop, there is nothing. So when will I come to this statement? When this if statement is true. So in our case, 1 is less than 4, right? So I'll be able to come out of the if statement or not. I can come out of the if, right? Now I'll go for the next iteration. What is the next 10? 7. See, these are nested for each, right? So the 4 remains as it is. Now the n is 7. So is 7 less than 4? No. So matched will not be changed. Match will remain 1. That 4 is matched with 1. So now the outer inner for each operations are over because the inner for loop is over. No more items in my noun list. So now where does this inner for loop end? Here. So you come out of the inner for loop and matched P is equal to match. That means in match D dictionary, there is an entry like this now. P is 4, that is against the pronoun at serial number 4. The corresponding noun is 1 at serial number 1. So after this, you again go for the next iteration in the outer for each. So what is the next P value? 10. So now P is 10. Right. Now you again check for the nested for each. So what is the first N? 1. Is 1 less than 10? Yes. So matched will become 1. Go for the next iteration. What is the next N value? 7. Is 7 also less than 10? Yes. So again update it. Now it is 7. After that, no more elements are there. So I'm not checking any further. I'm coming out of the inner for each block. Now matched dictionary will have 2 entries. 4:1 at 10:7.
7.
That means pronoun at sequence number 4 is matching to noun at sequence number 1. Pronoun at sequence number 10 is matching to noun at sequence number 7. That is, these are the preceding nouns, right? So now you can just come out of the outer for each as well, because all our entries are exhausted in both the lists. So this is how you can resolve pronouns. This is not a foolproof method. There will definitely be edge cases like I showed you. All it's not always that the preceding noun is the noun that the pronoun is referring to, right? But this will catch some cases. Like the example we took, that Rahul is working, he is busy. In that case, the pronoun is referring to the last preceding noun. So for these cases, this particular code will work. It will give you the correct nouns, mapped to the correct pronouns. Up to this, is it clear for everyone? Any doubt? From this resolving pronouns part, you won't get much question in exams, okay? Because again, this is not 100% correct. But this is just one way of mapping pronouns to particular nouns. Okay. So mainly these are the things that you have to study from week 7. Now, first you solve the activity questions. I won't solve them in today's lecture because this entire week is supposed to be week 7, right? So next class we will
Yes,
do
ma'am.
activity and practice together. Okay, so you solve them till Friday. On Friday class we'll discuss.
I think in week 8 also for dictionaries and some other concepts.
Your voice is breaking up. Come again.
I was saying that we have dictionaries, in some concepts related to dictionaries only in week 8 also.
Yeah, you will have both lists and dictionary related concepts till week 12 now. Okay. All the pseudocodes will have list dictionaries. So these two are the initial weeks, that week 5 to 7, you just start with lists and dictionaries. Rest of CT course will be using whatever we have learned till now. So week 8, week 9, all of these are heavily based on dictionaries and lists. Okay, week 8 will have this dictionary comparison, common elements. Okay, again, this resolve pronoun will again come. So again, how to use dictionaries with lists as values, all these things are part of week 8. Okay. So,
Syllabus for quiz 2.
yeah, syllabus for quiz 2 is weeks 1 to 8, but focus more on weeks 5 to 8. From weeks 1 to 4 also questions will be there, but 50 to 60% questions from the last 4 weeks, 5 to 8. Okay. So Friday class will discuss the activity and practice, so you solve it before that. Alright.
Hello. Your
Thanks, everyone.
16th, yeah, hello. So your 16th class is missing. It is not showing in the
Yeah, I saw that. I have connected with operations. We are trying to fetch that video. I'll upload it to YouTube. Okay. So,
Okay. Thank you.
yeah. Okay. Thanks, everyone.
Thank you, ma'am.
Thank you.
Anyone know what is the syllabus for CT? Quiz 2?
Week 1 to 8.
Sure.
Yeah.
Thanks.
Okay.